Okay guys, so I'm going to give you a really quick video about combinations and permutations. I'm not going to go into a lot of theory, but just give you some explanations by example and give you some ideas that help remember how things work. Basically, the key idea is with permutations, order is important. Combinations, order is not important. The way I find easy to remember about this is thinking about two different locks. You've all heard of combination locks, but I'm going to talk about a permutation lock. This is a permutation lock. You've got three lots of five letters there. You've got to choose three letters in the correct order to open the lock. Like B, C, D, goes like that. Combination lock, you just have to press three buttons at the same time. So B, C, D. Okay, both the permutation and the combination were B, C, D, but with the permutation lock, BCD is different to CBD or DCB or DBC or BDC or CBD, but with combination lock, all those things are the same. Okay, so there'll always be more permutations than combinations. Example with the permutation lock, how many possible permutations are there? Well, if the first letter is A, you could choose the next letter be A, and then the third letter be A, or the next letter be B, and etc. So if the first letter is A, you've got all them. First letter is B, you've got all those permutations. Sorry. So altogether, there's 125 different permutations, which, by the way, is 5 to the power 3. Because you've got 5 different options, A, B, C, D, E, and you have to choose 3 of them. Here's another permutation lock where there's no doubles allowed, so I cross them all out. And you can see that it's 60. But where's the 60 come from? Well, you got 5 choices for the first one, but you can't repeat that letter, so there's only 4 choices for the second letter, and then you can't repeat the first or the second letter, so there's 3 choices for the last letter. So altogether that's 60 different permutations. We'll look at some of these formulas later on. Combination lock, you just got to press 3 letters. Well, here are the different possible combinations, and that's 10 different combinations. Now, where does that come from? Well, this formula will help us. Okay, if you're choosing 3 letters out of a possible choice of 5, well, there's 5 combination, 5 factorial divided by 3 factorial, also divided by 5 minus 3 factorial, which will give you 10. This is a useful formula to remember. This is called 5 combination 3. Okay, keep going. Here's a couple other combinations examples. Mr. Hall was tennis coach. He had 6 players in his squad, but only 4 can make the team. How many different teams of 4 can be chosen from a squad of 6? Well, 6 combination of 4, or 6 combination of 4, you'll see the different notations. And on your calculator, it'll probably say NCR, which is what we've got there. So there's 15. But let me just prove that to you with some letters. A, B, C, D, E, F. There's your possible teams. You can see there 3 rows and 5 columns, 15. This little formula up here, 6 combination of 4 is 6 factorial divided by 4 factorial divided by 2 factorial, 6 minus 4, and you'll get 15 that way too. Okay, this theory works. I'm not showing you where it comes from. I'm just proving it, or it's not really proof, it's a verification. But there we go. Okay, one more example. This time I'm coaching volleyball. Got 8 players in the squad, only 6 can play at one time. How many different teams can be chosen from a squad of 8? Well, it's 8 combination 6, which is 28. There are the possibilities. You can make all sorts of nice questions here with, you're leaving the captain on, or you leave the setter on, or something like that. How does that change the different possibilities you can have? Okay, so really interesting things you could do here. I'm just illustrating to you here that you can choose, you can think about the 6 people who are actually going to play, or the 2 people that are going to be the reserves. Now you can see, if you cannot let them up, there's 28 different combinations there, and there's 28 different combinations there. That's the same number, because it's the same idea. Okay, so you can look in the positive sense of who's playing, or the positive sense of who's not playing, negative sense of who's not playing, and then you'll get the same answer. Just to quickly illustrate, 8 combination 6 and 8 combination 2, using that little formula here, you'll both get 28. You'll get 28 both ways. Okay, I hope that helped a little bit. That's only the briefest introduction. We're not really any proof, just some examples, but I hope that helps you get a grip on permutations, combinations.